Greetings from Rohini College of Engineering and Technology, Department of Chemistry delivers a series of video lectures in Engineering Chemistry course. In this module, we will discuss about the surface chemistry and catalysis. So this topic is already we have discussed in our lower classes. So in this module, we have discussed in application level. So before enter into advanced level, we should know about that what is meant by surface chemistry. So the chemical reactions which occur only at the surface is known as surface chemical reaction. So the reactions which are carried out at the surface. So first we should know the following, what is meant by adsorption. So adsorption is nothing but the phenomena of concentration of a gaseous molecules or liquid molecules at a solid surface is called as a adsorption. Either the gaseous molecules or liquid molecules or a solid molecules which may occupy a solid surface is known as a adsorption. Then adsorbate. Adsorbate means the substance which is held on the surface of the solid is called as a adsorbate. Adsorbent means the solid that takes up the gas or a solute from the solution is known as a adsorbent. The best example is in our classroom when our class teacher rubbed the board, the chalk particles adsorbed on the duster surface. That is an example of adsorption. So the duster is an example of adsorbent. So in its surface only the dust particles, the chalk particles are adsorbed. So the chalk particles are called as a adsorbate. So this physical process is called as a adsorption. This chemical reaction carried out only at the surface of the duster. So this reaction is called as a surface reaction. So adsorption is nothing but the phenomena of the concentration of the gaseous molecules or liquid molecules or a solid molecules which may occupy at the solid surface is called as a adsorption. Adsorbate means the substance which is held on the surface of the solid is known as adsorbate. Adsorbent means the solid that takes up a gas or a solute from the solution is known as adsorbent. Let us take another one example. Let us take one sponge. We add 1 or 2 drops of water. So what happened means the water molecules are penetrated inside the body of the sponge, not only at the surface. So it is an example of absorption. So it is a bulk phenomena. It's a process of the substance uniformly distributed throughout the body of the solid. It is known as a absorption. So sorption is nothing but both adsorption as well as absorptions are simultaneously takes place. Both processes are simultaneously carried out means it is known as a sorption. Occlusion. Occlusion means the adsorption of gaseous molecules on a solid surface is known as a occlusion. Only the gaseous molecules occupy the solid surface is called as a occlusion. Okay. So these diagrams indicate that the adsorption, absorption and sorption. So the first diagram indicates that the small rounds indicates the adsorbate. The big round molecule indicates adsorbent. So on the adsorbent surface the molecules are occupying. Only at the surface the molecules are occupying. So it is an example of adsorption process. In the second example, the gaseous molecules or any molecule, the molecules occupying both the surface as well as inner part of the body. So the molecules are uniformly distributed throughout the body. So it is an example of absorption. Then in the third case, both adsorption as well as absorptions are carried out. So the molecules occupying at the surface as well as it is enter into the body, inner part of the body. Both adsorption as well as absorption both are carried out. It's an example of sorption. So now we discuss about the difference between adsorption and absorption. So we know that adsorption is a surface phenomena. So the chemical reaction only takes place at the surface. So it talks about the surface. So it is a surface phenomena. This type of reactions are carried out in the fast manner. So it is a very rapid process. The equilibrium attainment also takes place in the fast manner. Here the concentration of the molecules are more on the surface and less in the bulk. So more or less more and more quantity of the molecules are occupying only at the surface only. But in case of absorption, it is a bulk phenomena. The molecules are uniformly distributed throughout the body, both surface as well as inner part of the body. It is a slow process. So in order to carry out this absorption process, it takes more time. The equilibrium attainment also takes more time. So here the molecules distribution is uniform. So in adsorption, in particular area the more molecules are occupying, but in case of absorption the molecules are uniformly distributed. So these are the difference between adsorption and absorption. Of hydrogen or oxygen on charcoal. Similarly in chemical adsorption, chemisorption example, the adsorption of hydrogen on nickel. So now I give one simple example. Let us consider the same duster. Okay, so when we rub the board continuously, the chalk particles are adsorbing on the duster surface. So at a particular time we cannot rub the board clearly. So at that time what we do, we just dust the duster on the wall. So what happened means all the chalk particles are desorbed from the duster surface. So here the desorption process takes place. Why desorption process takes place means both the force held between the adsorbate and the adsorbent is weak. So we can easily separate both the adsorbate and the adsorbent. So here the force of attraction held between the adsorbate and the adsorbent is weak van der Waals force. So it is an example of physical adsorption. But in case of chemical adsorption, let us take the iron bar. It is subjected to rusting. Okay, so the rust particles are deposited on the surfaces of iron bar. Okay, so the rust particles are adsorbate, the iron bar is the adsorbent. Once if we remove the rust particles from the iron surface, we cannot once again place the rust particles on the iron surface once again. So what happened means, due to strong covalent bond force of attraction held between the rust particle as well as the iron bar, the force held between these two is very strong covalent bond. So once we separate these two, we cannot make it rejoin once again. So this is an example of chemical adsorption or adsorption. So let us consider the hydrogen molecules adsorbed on the surfaces of nickel. So initially it undergo physical adsorption. So the weak force of attraction held between the nickel surface and hydrogen molecule, after that it undergo chemical adsorption. So a strong covalent bond making held between the adsorbate and as well as the adsorbent. Let us see the characteristics of adsorption. So we know that adsorption is a spontaneous process. It is a continuous process. During adsorption, some quantity of heat energy is evolved. It is accompanied by both decrease in enthalpy as well as entropy of the system. It is a selective process. It depends upon temperature. It depends upon nature of the adsorbent and adsorbate. It is a physical phenomena but accompanied by chemical change. So we know that in order to carry out adsorption reaction, the main factors are the adsorbent as well as adsorbate. So both factors are very essential. Similarly, the temperature, pressure and concentration factors also essential for inducing the rate of adsorption. Similarly, it is a spontaneous process, selective process. During the adsorption, some amount of heat energy is evolved. It is accompanied by decrease in both enthalpy as well as entropy. It is a physical phenomena but accompanied by chemical change. Now we see the difference between physical adsorption and chemical adsorption. So we know that physical adsorption is nothing but it is due to weak van der Waals force of attraction. Chemical adsorption means it is due to strong covalent bond, strong chemical bond formation. Here the heat of adsorption is low. So during physical adsorption, heat of adsorption is nothing but the amount of heat energy evolved when 1 gram of gaseous molecules occupy at the solid surface. 1 gram of molecules occupying at the solid surface, how much amount of heat energy is evolved, that is called as a physical adsorption. So the heat of adsorption is low because we have to spend only a small quantity of energy to remove the adsorbate from the adsorbent. So the heat of adsorption is very low, but in case of chemical adsorption we have to spend more quantity of energy to occupy the molecules at the solid surface. So for nearly 40 to 400 kilocalorie of energy is needed. Similarly, it is a physical adsorption is a reversible process. It is a reversible process. Both adsorption as well as a desorption, both are carried out in physical adsorption. But in case of chemical adsorption, irreversible process, only adsorption takes place. We cannot form the adsorption reactions from the desorption. Okay. Similarly, physical adsorption reaction decreases with increase in temperature. So when we are increasing the temperature, the physical adsorption is decreases. But in case of chemical adsorption, it increases with temperature. Chemical adsorption increases with temperature. Similarly, physical adsorption is in physical adsorption, multilayer formation is possible. So why the multilayer formation is possible means because due to less force of attraction between the molecules, just the molecules are occupying at the surface of one layer surface to another layer. But in case of chemical adsorption, only monolayer adsorption only possible. The rate of adsorption increases with increases of pressure and concentration. So when we are increasing the pressure and concentration, automatically the physical adsorption rate, speed becomes increases. But in case of chemical adsorption, the increases of pressure and concentration is decreases when the speed of chemical adsorption. Similarly, the equilibrium attainment takes place very fast in physical adsorption, very slow in chemical adsorption. The surface compound formation takes place in chemical adsorption. Why chemical surface compound formation takes place means because the molecules are more active, so they have enough energy to interact with each other. The nearby molecules are interact, so they can make the compound formation. But in case of physical adsorption, the molecules possess less energy, so they cannot interact with each other, so they do not form the surface compound on its surface. Similarly, it involves very small activation energy. Chemical adsorption involves appreciable energy. Okay. Now we see the factors influencing adsorption of gases on the solids. Factors influencing adsorption of gases on solids. So we know that the nature of gases, the easily liquefiable gases are readily adsorbed than ordinary gases because they possess high van der Waals force of attraction. High van der Waals force of attraction. Easily liquefiable gases like hydrochloric acid, ammonia, chlorine, sulfur dioxide, which are readily adsorbed than that of permanent gases like hydrogen, nitrogen, oxygen due to critical temperature and van der Waals force. So these are the main reasons for increasing the rate. Okay. Then next one, nature and surface area of the adsorbent. If the area is greater, adsorption also greater. If the area of the adsorbent is greater, the adsorption also greater. Similarly, if the adsorbent possesses larger pores, larger is the adsorption because the pores permit the diffusion of gases. So through the pores only the gaseous molecules undergo diffusion. Then heat or enthalpy of adsorption. We know that the energy liberated when 1 gram of gaseous molecules adsorbed on a solid surface. So in case of physical adsorption, the heat of adsorption is small. In case of chemical adsorption, the heat of adsorption is large. Similarly, reversible character. So reversible character means we know that both adsorption as well as desorption, both processes are carried out. So physical adsorption undergo reversible, chemical adsorption is a irreversible one. Similarly, effect of pressure of a gas, effect of temperature and the effect of concentration. So these three factors determine the rate of adsorption of gases on the solids. Similarly, the activation of the adsorbent. So activation leads to increase in the surface area of the adsorbent, which leads to increase of adsorption. So activation is achieved by two ways. One is creation of rough surface area by doing mechanical rubbing as well as by doing some chemical reactions on the solid surface. Similarly, increasing the effective area by subdividing the solid adsorbent into fine particles as well as heating in a superheated steam. So the pores also opened and the adsorption also increases. So these are the factors which induces the adsorption of gases on the solids. So already we have discussed. Now we discuss about the adsorption of solutes from solution. So adsorbents adsorb dissolved substance from solutions. So it can adsorb the coloring matter present in the sugar solution. Similarly, it adsorbs acids like acetic acid and oxalic acid present in water. An adsorbent also adsorbs certain substance from the solution in preference to other substance. Example, charcoal and also alumina. So it adsorbs non-electrolytes more readily than electrolytes from a solution. But in case of alumina, it adsorbs electrolytes more readily than non-electrolytes from the solution. So the factors influencing the adsorption of solutes from solution. So the extent of adsorption depends upon the following factors. One is the effect of temperature and concentration, effect of surface area, the nature of solute adsorbed. These three factors. Okay, these three factors induces the extent of adsorption. One is effect of temperature and concentration. Then second one is effect of surface area. Third one is nature of the solute. Okay, so effect of temperature and concentration. When an adsorbent is dropped into a solution, a solute or solvent may adsorb. When the solute is adsorbed by an adsorbent, it is called as a positive adsorption. If the solvent is taken up by the adsorbent, it is called as a negative adsorption, the adsorption of water. So this what means that the extent of adsorption of a substance from the solution depends upon temperature as well as concentration of the solution. When the adsorbent, that is the solute, is dropped into a solution, either the solute or solvent may be adsorbed. When the solute is adsorbed, it is called as a positive adsorption. If the solvent is taken up by the adsorbent, it is called as a negative adsorption. Similarly, the effect of surface area. Already we know that if the surface area of the adsorbent increases, the adsorption also increases.